So now we finally reached the third generation of mobile communications. But first of all, what is the third generation? The third generation is basically defined by certain requirements. So in the end, it's not a certain technology, but all the technologies that can fulfill certain requirements when it comes to data rates. For example, rural areas 144 kilobit per second or up to 2 megabits per second in urban areas. So that's the basic idea of having a single, that was the original idea, a single system that covers the whole globe, well, in ideal scenario, offering a certain number of kilobit per second with goals or minimum requirements in rural, suburban and urban regions. IMT 2000, well, the name, well, should symbolize a bit that this is a technology that should start around the year 2000, but also will operate around 2000 megahertz. So, before we had the 3G systems, the ITU said, okay, these are the goals, and now please different standardization bodies, companies, whoever wants to propose something, propose systems for that. So there were different ultra-wideband systems, CDMA 2000, also different other CDMA systems, and ETSI from Europe, the organization that already standardized GSM, came up with UMTS, the so-called Universal Mobile Telecommunications System. And UMTS now serves here in this lecture as an example for a 3G system. As we will see, it's not the only 3G system. It's one example, a very successful one. Well, the most successful one, similar to GSM, the most successful second generation system. So UMTS is one of the proposals. So UMTS consists of UTRA. UTRA is now called the Universal Terrestrial Radio Access. So a radio access part covering the radio parts was called UMTS. Now for marketing it's better universal, because as well cover later, there was really a fierce fight going on about patents when it comes to UMTS. UMTS was also seen as an enhancement of GSM. So, well, Edge, we'll talk about this. Edge can be seen in this context, enhanced data rates for GSM. That's GSM up to 384 kilobit per second. There was different other enhancement like virtual home environments, like customized application for mobile enhanced logic, etc. There was a whole global multimedia mobility initiative from ETSI. So it was not only data rates, but also how can you hand over mobile communications not only within a single system, but also from your working place to your home, to your car, into a train, and the whole system somehow follows you. So these were the keywords, so you can look them up. So, what did the ITU do? The ITU set some goals, some requirements, but the ITU also came up with certain frequencies. So, 1992, there was a World Radio Conference, and the ITU allocated a certain part of the spectrum for the IMT 2000, the International Mobile Telecommunications in the year 2000, around 2000 megahertz. So this allocated spectrum contains a part of the spectrum for terrestrial services, here denoted as IMT 2000, plus mobile satellite services, here shown in orange, an uplink and a downlink. And for the satellite services, well, this should be roughly the same spectrum around the globe. But as you can see, the spectrum the ITU thought of was not really available everywhere anymore. So that was the setting at the end of the 90s. Europe already had the GSM 1800 system, plus the digital cordless telephony, the DECT system. So the DECT was here already in the IMT spectrum a bit, but DECT, the classical DECT, came from the second generation ideas. I will come back to this. And then Europe decided, okay, we will have a part of the spectrum for TDD, time division duplex, and a part of the spectrum, a paired band for FDD. So this is our paired band in Europe. China had basically the whole spectrum still available. In Japan, it looked a bit different. We had the PHS system, the personal handy phone system. And in Japan, the government said, okay, maybe we can have different technologies. A CDMA 2000 based 3G system and a wideband CDMA 3G system. Wideband CDMA, as we will learn, is the technology behind the European UMTS system. So in Europe, most governments decided also the technology and said, no, we will not have different technologies, but well, it's better to have a single technology. There were different approaches, so the company could go for one or the other technologies, as we'll see. But in Europe, usually we only had UMTS. So we had the UTRA FDD paired bands and the UTRA TDD unpaired bands. In North America, we had a situation that we already had cellular systems operating around 1900 megahertz. You remember the GSM system, for example. And in the beginning, we had also certain reserved spectrum, for example, for military, and then some spectrum for satellite service. So in the beginning, it was not really clear how to start with the 3G systems in the US. So, but the basic idea was in the beginning to have one common global standard. The end of all efforts around INT 2000 was not really a single common standard, but rather a family of different standards. Why? What was the reason? Well, one of the reasons was we had many different standardization bodies, companies, and a lot of political interests. Just the idea of using CDMA technology caused a real fierce patent battle between Nokia Ericsson and Qualcomm, for example, because Qualcomm had many CDMA patents, CDMA-related patents, but Nokia and Ericsson had a lot of core infrastructure patents. So after the exchange of almost 2,000 patents, well, at least the companies could continue developing their products. There was even the problem that in the US it was said that, okay, we don't want to have European technology, UMTS, but we want to have our US technologies, and then US companies told the politicians, well, we manufacture a lot of this so-called European standard, which is GSM or also UMTS standards. So there was a lot of fighting going on political level, industrial levels, so the European Union against the US, etc., etc. The end of the story was that we did not come up with a single standard, but with this family. And whoever already used GSM and had a core network that was geared towards GSM stayed with this GSM core network and added UMTS. Whoever had the CDMA 1 system following the IS-95 standard stayed with this core network and went further on with the CDMA 2000 standard. So here in this lecture I will focus on the most successful system, which is the UMTS system. So where do we find UMTS? Oh, nowhere it's written UMTS. Well, here, initial UMTS, here you will find it. Why is it that complicated with all these acronyms? Well, first of all, the ITU thought about the core network. So that was the ITU. T, so the telecommunication sector, core networks needed for the mobile network. Core networks could be the internet, IP network. No one went that far at that time. Today that's different. But most of the operators stayed with, for example, the GSM core network for the third generation. And then, in addition to that, we needed the radio access. Radio access defined by the ITU R, the radio section. And here exactly we had the problem. We could not agree upon a single standard. So in the end, the family contains 5 different standards. The ITU calls them IMT, International Mobile Telecommunications. So these are the ITU acronyms. And there we have the so-called direct spread. I will come back to how we directly spread in this technology. We have the time code, multi-carrier, single carrier, and frequency time. So it's interesting to see that the classical DAC system, the cordless telephony system, fulfills the basic requirements for 3G, although no one will call this really a 3G system. It fulfills the requirements. What else do we have? 3GPP was formed for the third generation. It's called a partnership project, and it's basically a successor of ETSI, integrating some more partners. And today 3GPP standardizes everything around UMTS and then LTE and all the following technologies. 3GPP and in parallel 3GPP2 was founded for the CDMA1, IS-95 and then CDMA 2000 operators. So the ITU calls them IMT, DSTC, whatever. The technology used internally is then called, for example, well, it's a wideband CDMA system, or it's a time division synchronous CDMA system, or it's whatever system. So you see, there you can see the technology, and the standardization bodies like 3GPP then has their own acronyms. For example, UTRA FDD, that's the Universal Terrestrial Radio Access using FDD, or UTRA TDD, both UMTS technologies using different duplex schemes based on different multiplexing technologies. But you see, this is a key characteristic of many of the 3G technologies. They use CDMA. CDMA, we talked about this as multiple access and multiplexing scheme. This is why Nokia Ericsson needed many of the patents from Qualcomm in this example. There's another technology that it's based on the former IS-136 standard. It's the UWC 136 standard. It's a more wideband system, but using this single carrier technology. Not that successful in the market. The most successful ones in the end were the technologies called UMTS using FDD. Not the TDD system, was not that successful in the market. Also not the Chinese version. It's all there. So we have these technologies, but not the major breakthrough. And then additionally, the CDMA 2000 system for all the operators already using IS-95 or CDMA1. So, is confusing. We will start the explanations based on UMTS. UMTS, that was the marketing name in Europe for this Universal Mobile Telecommunication System. In Japan, it was called FOMA. And we start here with the release 99, so the initial standard of UMTS, to teach you the differences to GSM. And we stay with the FDD system. So that is the classical system, the classical UMTS system you see on the majority of mobile phones. Yes, there were many experiments, even systems with TDD, some other technologies. There was a fight going on between China and Europe, etc., etc. So you see, it's not only technology, but a lot of political and industrial, economical interest behind this. Because everyone noticed, oh, this will be a big technology. This is not voice only. This is now something really, really big. So before we come to this really, really big in terms of money, first of all, what is this Release 99? So, if you dig a bit deeper into the different standards, you will find at 3GPP, accessible for everyone, different releases and stages of standards. I have to clarify this, otherwise you will not understand what's going on there. Okay, no matter if you look today at GSM, at UMTS, at LTE, and everything that comes up, or still today and for the next years, you will find the so-called releases. So releases here, just a snapshot. Release 12, 11, today we have 14, 15, 16, 17, and etc., etc. So the releases basically will tell you, okay, now we have new features, really new features in the systems. And you see, for example, releases going down to release 4. Before that, we had something like, release 99. Why switching between, from this numbering to the other numbering? Well, in former times, release 99 was meant to be finalized in the year 1999. So each year a new release. But that really put too much pressure on the standardization body. So around the year 2000, they switched from this counting the years into counting releases, and the releases are now more or less independent of the years. So we do not have a new release each year. Rather a new release, well, each time you really have something fundamentally new. So, okay, by looking at the standards, you have to keep this in mind. What else? All the standards, they have a numbering. And the numbering, you will see the release number here. Yes, there are some confusions. Release 4 has the number 4 as well as the phase 2 of GSM. Okay, look at the year. You will see there's a difference. But from the year 2000 on, you will see release numbers. They are reflected in the specification number. So we have releases. Releases cover aspects of GSM still today, and UMTS and LTE, and whatever there will be. The new radio, 5th generation, etc. So you will not see the generations here. You will not see a separation by technology, but you will see specifications of release 8 that are related to UMTS, that are related to LTE. Within a release, you have so-called stages. What does it mean? Officially, you have 3 stages, 1, 2, 3, but there are also the unofficial, but still mentioned on the web pages, stages 0 and 4. Before you start with standardization, you are in stage 0, which is a basic feasibility study. So you basically say, okay, we could do something like a data rate of 1 gigabit per second. It's feasible. So in the lab we showed it's a gigabit per second. Or we can use MIMO, for example. Or we can have a special low delay class for machine type communication, something like this. So it works in the lab. And then after discussion, you start with stage 1. Stage 1, that means you describe the service from a service user's point of view. You do not describe implementation or what's internally, which kind of elements you need. It's just the service. So for example, the user will get 1 gigabit per second. Okay. Then at least we have a service and an interface. And then we look at stage 2. Inside this box that should offer the service, we break down the problem into some elements and information flows. And so we have to know, okay, for offering 1 gigabit per second, we need this and that. We need certain information that comes from this element and from that element. So we somehow fit this idea of a new service into the architecture. In stage 3, we already have concrete implementations of the protocols of the different elements. So this is the mobile device and this is the antenna, and to offer this 1 gigabit per second we need this and that modulation scheme and coding and encryption and whatever there is. And after we've done this, well, we have to test the whole thing. So you can look up all the releases, follow the link shown here. So that's the idea. Okay, that was just to clarify the idea of why release 99 and now we have release 17 and what is the difference and what are these stages. And you see also the typical freeze state of a certain stage. So after you freeze a stage, you will not change, for example, this logical analysis, the breaking problem down to the elements, etc. Okay, so now coming back to UMTS, think back. We are somewhere in the year 2000. Yes, we had the dot-com bubbles and all these problems, but that was later. We were still in a situation where everyone said, wow, this is where we can make billions of euros and dollars and yen and whatever, because this is really the holy grail of mobile communications. We have the internet on the mobile phone. There was a lot of fake information in commercials that someone talking to the mobile phone, downloading pictures while falling down and a parachute and then down to earth, and then the delivery service delivered a new whatever couch and the guy just dropped on this. And UMTS was also marketed as this is the internet on your mobile phone, which in fact it was not. It was not at all. So if you look back in the history, UMTS and the ideas behind that were initially, created by Nokia Ericsson, the companies. Nokia, for example, at that time, looking at a new technology that could fulfill the requirements needed for voice communication, especially in Japan. Because the classic second generation systems used there did not have enough capacity, so they looked for more capacity for voice communication. So the focus during the design of UMTS was not on packet, on data transmission. And this is also reflected then, for example, in the auction. So why having an auction? Well, auctions is one way of giving away the licenses for a spectrum. Spectrum is a scarce resource. So usually the authorities, the government says, okay, if we give a spectrum to a certain operator, we give something that belongs to the people, to a company, then at least the companies should pay for it. Because, the spectrum, that's like whatever, the ground, whatever, it belongs to the people and not to a certain company. So the governments give away spectrum. And then there's one way of doing it that's called a beauty contest. So the operators can say, okay, we will do for the next 20 years this and that and these nice services. And then the government say, okay, we like your concept. We give you the spectrum for this and that amount of money. And then there's another way of doing it. It's called an auction. And going back to the year 2000, I remember that all the companies in Germany especially said, we will have an auction. Because this is the market, let the market decide. An auction is basically that you offer an amount, and if someone else offers more, the other one gets the spectrum, then you have to offer more. So, and then we had the situation that although all the techies already knew UMTS will not offer the internet on the mobile phone, but in the very beginning, this is rather something like, okay, faster data rates than GSM, but still not the same as the internet. Plus, at that time, the companies developed the UMTS system mainly for voice communication. And voice, you already know, uses paired bands because you have this symmetric situation of two people talking to each other. So same spectrum in the uplink and in the downlink. So, mid-August 2000, that's the example from Germany, we had a situation that the government said, okay, we have the paired bands, that's the paired band, where we have the same spectrum on the uplink as we have on the downlink. And in the end, we will license 12 channels, each 5 megahertz. Okay? And to be successful in the auctions, you have to have at least 2 of the channels and a maximum of 3 of the channels. Okay? As an operator, at least 2 maximum 3. So that in the end, this allows for either 6 operators, each having 2, or other combinations, or 4 operators, each having 3. Okay? And then, additionally, we have the unpaired band. Okay, unpaired. So unpaired, yes, TDD, there were not really mobile phones available. I remember still big containers. There were some more problems with the TDD technology. FDD, the devices were already available and the technology up and running in some of the countries. Additionally to the license, the government had some requirements. You have to cover a certain percentage of the population, 25% until end of December 2003, 50% until end of December 2005. That's valid for Germany. What does it mean? End of 2005, 50% of the population should be able to use the new UMTS technology. If you're not able to provide this coverage, you will lose the license and you will not get your money back. All the companies knew this. Okay, so what happened in Germany? We had 4 companies that already had networks. T-Mobile, that time still T-Mobile. We had at that time also a company called Mannesmann Mobilfunk, today Vodafone. We had E+, not existing anymore. And we had Fiat Intercom, today Telefonica O2. So those 4 companies already operated base stations, so real base stations. There were 2 more companies, Group 3G and Mobilcom Multimedia. They were up to this point either not existent, so a new group like 3G. There was the Finnish Sonera behind it, etc. And we had a virtual network operator offering services via the network of other operators. So 4 real physical operators and 2 others. So everyone knew, okay, if I'm a newcomer, I have to build many base stations. Because to get a certain reliability in the system, the government said you're not allowed to use the same antenna. So you have to install your own antenna. So in case of failures, at least customers can go to another operator. What happened? In August, 18th of August, there was an auction going on with many rounds. And in the end, the licensing was 50-something billion euros. 50 billion. And everyone knew you have to invest at least, again, 50 billion into the infrastructure. Extremely high sum. And the end of the story was that all 6 companies wanted to have UMTS spectrum. So everyone only got 2 channels out of the 12. So 6 times 2 channels. Because everyone wanted to have 3 to cover, well, to have higher data rates, to offer better services. And the TDD, well, was almost ignored. It was only something like 280 whatever million, so not that much. So 50 billion, that was quite a lot. And just to come to an end with this story, at the end of 2005, 2 out of these companies could not really cover the population, could not fulfill this requirement, and they simply dropped out. So they could have stayed away from the very beginning. They lost a lot of money because the government did not pay back this, let's say together, 17 billion euros. Okay, it was rather invested in academia, for example, which was a good idea. Okay, so that was the end of the story. 2000, so 20 years ago. Then the remaining part of the licenses were then licensed in the upcoming years. But that was the story about this extreme licensing. And today, looking at LTE, for example, all the companies try to avoid these extreme rays they had for this UMTS licensing. Now let's start with the technical part of UMTS. As I already said, we use here the release 99 as a starting point because here it's easier to show the key differences to GSM or what do those systems have in common. And I will explain newer releases then in the context of LTE because now LTE is more and more the dominating system. But you have to understand the basic ideas there to understand why we made the change then again from UMTS to LTE and why we did not continue with UMTS. So UMTS, similar to GSM, consists of different systems. So we have the UTRAN, which is the radio access part, and there we have a network here in between. That's the UTRAN, and this is responsible for mobility at cell level. There we will have the radio network subsystem, and there we basically encapsulate all these radio specific tasks. Then we have an interface IU towards a core network. Here the core network is whatever we use as a core. Here we do handovers between systems, from a satellite to terrestrial, from maybe a wireless LAN to whatever. You see, this sounds a bit more generic than GSM. So this is what we do there. And if we do not have a connection between the user equipment and the UTRAN, then we do location management there. Because the user equipment, which is now the new name for our MS, remember in GSM we call this a mobile station. Now we call it user equipment. The user equipment could be connected to another network as well, which is not connected to the UTRAN. So this is a very rough breaking up of this architecture with the interfaces. An interface you already know. This was the UM interface in GSM. Now it's the UU interface, the U interface for UMTS. That's our radio interface. So here we have the wireless connection in between the UTRAN and the user equipment. Additionally, UMTS defines many more interfaces and domains. Domains, that's something new. The domain, for example, we have for the user equipment. User equipment, here we see our air interface, the UU. Inside the user equipment domain, we see the device, the mobile equipment, and again our SIM. You see still the separation of the SIM, which is now called the USIM with new features, a USIM, and the device itself. And the user equipment domain is assigned to a single user in order to access the UMTS services. Then we have an infrastructure. That's usually the fixed part here, our infrastructure. The infrastructure that is shared among the users, and this infrastructure offers the UMTS services to all the users. Within the infrastructure domain, we see the core network. Core network, this is where we have usually our fixed networks and the access network. Access network handling all these radio specific things in UMTS. And the core network itself consists of a home network. This is where your device and you belong to. That's your home operator, for example. A currently serving network and a transit network. What is the difference? Well, transit network, maybe you're talking to someone else in some other network. Then transit network will transfer your data. The serving network is the network where you're currently attached to. But this could be from any network operator. And then we have the home network. Remember, similar to GSM, the home network answers, for example, call setup requests. Home network has the database with all the subscriber information. So this is a more generic view. Serving network, there you will find databases for visitors, etc. So, to explain it in some more detail, within the UMTS network you will find again a SIM, the Universal Subscriber Identity Module. And this is now important again for encryption, authentication, as we know it from GSM. And that's our SIM. And this is what you insert. Well, either as a SIM or as an eSIM, as a chip integrated in your device. The mobile equipment domain, that's the device you hold in your hand, has all the functions for radio transmission, and this is what you use to set up and to maintain your end-to-end connection. Access networks in general do everything that is needed for you to access the network with different technologies, and the core, as I explained, that's really usually the fixed infrastructure where you have everything else that is not depending on the different access technologies. Because in this picture, you could still have a GSM network as an access, or you can have a UMTS network, or you could even think of satellite links or wireless LANs or whatever. You see, this is a bit more generic, this breaking up the whole system into different parts. Okay, that was the first part about UMTS. Back to some questions. What defines this third generation? What was the initial idea behind it? And then what really led to the different developments? There are so many different reasons for this. 20 years ago, we did not come up with the single systems. Go to the pages of 3GPP, check, understand the ideas of the stages, releases, etc. Early UMTS, what was the focus there? It was a replacement for something. And how do we see this when we look at the spectrum? When we come to the licensing, what is the problem of this condition? You have to cover a certain percentage of the population. Well, it's a problem if you cannot fulfill this condition. But the condition itself is problematic. Why? There are different perspectives. And what was, again, the reason for the operators that already used GSM then to pick UMTS as the third generation, and the operators using CDMA 1, IS-95 to go for CDMA 2000? There are quite obvious reasons for that.